As you know, precision engineering absolutely matters, especially when any rocket blasts off for a space mission or when a fighter jet takes off for any purpose. The engines, which are the core of these machines, accelerate the heavy aircraft into the air. Now, what happens if the engine exhaust nozzles are diverted to change the object's direction or maneuverability? Even if you see this video footage, how it is possible to turn a super fast fighter jet into those agile maneuvers? In today's thrilling episode, we unveil the cutting-edge secrets of thrust vectoring technology in modern military aircraft. Let's discover the incredible advancements that give these machines unparalleled agility and power. But that's not all. We will also reveal which state-of-the-art missiles are equipped with this game-changing technology. Jai Hind dosto, welcome back. This is Prajesh and you are watching AirPra. Thrust vectoring is an advanced technology used in aircraft, missiles, and rocket propulsion systems to enhance maneuverability and control. Unlike traditional engines that direct their exhaust straight back, thrust vectoring allows for the redirection of exhaust gases, enabling the vehicle to alter its direction more dynamically and quickly, along with the altitude or angular velocity of the vehicle. By manipulating the direction of thrust, also known as thrust vector control or TVC, either by rotating the engine nozzles or using vanes or pedals within the exhaust stream, thrust vectoring provides additional control over pitch, yaw, and roll movements. This capability is invaluable in situations requiring rapid changes in direction, such as distinctive maneuvers for fighter jets or precise landing maneuvers for spacecraft. Several types of thrust vectoring mechanisms are used in rockets and missiles to control their flight trajectory. I have included a link in the description to read more about these methods. Jet vanes thrust vectoring is a crucial feature in modern atmospheric tactical missiles. Jet vanes are movable surfaces positioned in the exhaust stream of a rocket engine. They regulate thrust direction by redirecting exhaust gases. Actuated by onboard systems, they adjust to control the missile's trajectory during flight. Jet vanes offer precise maneuverability, crucial for stabilizing and steering advanced missiles. Some contemporary air-to-air missiles, such as the American origin AIM-9X Sidewinder, British ASRAAM, Russian R-73, Chinese PL-10, German Iris-T, French Mika, and Indian origin Astra utilize this technology. Additionally, surface-to-air missiles such as the Russian 9K330 Tor, the Chinese HQ-9, a derivative of the Russian S-300, and the Indian origin Quick Reaction Surface-to-Air Missile QR-SEM and Barak-8 also employ jet vanes thrust vectoring. Anti-tank missiles such as the Indian MPA-TGM, the German Pars-3LR, and the French Irix also utilize jet vanes thrust vectoring. Overall, jet vanes thrust vectoring plays a vital role in maximizing the lethality and operational capability of tactical missiles, ensuring they can accurately engage targets and accomplish their mission objectives with agility and precision. In addition to these, various other missiles also employ thrust vectoring technology. Missiles such as the Indian origin Akash, the Franco-Italian Aster-15 and Aster-30, and the Russian 9M96E of the S-400 surface-to-air missile, as well as the 9K-720 Iskander short-range ballistic missile and the BrahMos cruise missile utilize thrust vector control (TVC) to guide themselves towards the target until the very last moment of impact with precision. This technology enhances maneuverability, enabling the missile to execute sharp turns, adjust its trajectory, and effectively evade enemy defenses. If you want to explore the details of these missiles I have just mentioned, please log into airpra.com. You will love reading them all. Thrust vectoring technology in modern military aircraft represents a peak in aerospace engineering, transforming how these aircraft maneuver and perform in combat situations. Initially developed to provide vertical or short takeoff and landing capabilities through upward vertical thrust, its potential in combat became clear by the late 20th century. To perform dynamic instantaneous turns, which can lead to 7G plus forces, aircraft without thrust vectoring must rely solely on aerodynamic control surfaces such as ailerons, elevators, and radars. However, aircraft with thrust vectoring nozzles can achieve most of their super agile maneuvering through these nozzles using controlled surfaces to a lesser extent. The British Harrier was the world's first operational fighter jet with thrust vectoring, enabling vertical takeoff and landing capabilities, followed by the Soviet origin Yakolev Yak-38 and Yakolev Yak-141. As of 2024, only 2 operational short vertical takeoff aircraft exist: the McDonnell Douglas AV-8B Harrier II and the Lockheed Martin F-35B variant. However, it is important to note that these aircraft are not designed to execute complex maneuvers with unprecedented agility and precision. They are designed for aircraft carrier operation, enabling shorter takeoffs and landings. Thrust vectoring flight control, in short TVFC, is achieved by deflecting the aircraft's jets in one or more directions, such as a pitch, yaw, and roll. In extreme cases, this deflection creates the necessary forces and moments to fully control the aircraft's flight path without relying on conventional aerodynamic flight controls. Currently, the most successful operational fighter jets using TVC include the Russian origin Sukhoi Su-35S and Sukhoi 57 Falcon for the Russian Air Force, as well as the Sukhoi Su-30 MKI operated by the Indian Air Force. Although the Lockheed Martin F-22 Raptor's exhaust nozzle is designed to perform pitch only, it still enhances aircraft versatility to a greater extent. By adjusting the thrust direction, often through movable nozzles or vanes, these aircraft can perform intricate maneuvers with unmatched agility and precision. This enhancement boosts their aerodynamic capabilities in both subsonic and supersonic flight, facilitating swift changes in direction, tighter turns, maintaining near zero airspeed at high angle of attack without stalling, and ensuring enhanced stability in intense combat scenarios. Thrust vectoring technology offers numerous tactical advantages in aerial combat, including increased survivability, enhanced evasion tactics, and improved weapon delivery accuracy. It allows pilots to outmaneuver adversaries more effectively, maintain situational awareness, and gain the upper hand in engagements. In this video, without delving into too many engineering details, I have simply aimed to introduce you to some of the advanced fighter jets and missiles that are equipped with thrust vectoring technology. I believe you now understand the importance of this technology. Then please do not forget to like and subscribe to the channel. Stay tuned for more informative content on military technology. Until next time, take care, stay updated, and goodbye.